Hello, everybody. Welcome to 10-6 conic sections. We're just going to go through a few pull together ideas that I think will be familiar to you. So we'll talk about how do you determine what conic section you have based on what we call the general equation, which is on your first slide here, and then their standard forms, which is easier to graph form. So we'll talk about all of those. So the general form is up on your slide here, the ax squared and so on. The a, the b, c, d, e, f, those are all just numerical coefficients. So we'll talk about how we can determine each of those. All right, so first order of business, I have a few examples for you here. Let me move these so you can see. All right, so I have 4 examples for you to jot down, and I want you to take a look and see if you can identify which, this is by their standard form equations, which graph each of these are. So I'm going to take a peek and kind of walk you through each one of them, so as you write them down. First one, if you notice, there's only one squared term. So if you have one squared term of our 4 conic sections, which one would that be? Pause for effect. Parabola, right? So this one is y equals, so it's opening either up or down. This one has an a value that's positive, so it open up. Okay, how about number 2? Take a look at that equation. In this form, which of the remaining 3? And it looks like to me that that would be a circle. So you have 2 squared terms. It's equal to the radius squared. Center would be at 1, -3. Radius is 5. Okay, number 3, take a look at that one. You have 2 squared terms, and you have the fraction, so it's either an ellipse or a hyperbola. We can tell by the signs. If you notice, the sign of this one is a minus, so it's a hyperbola. And then that leaves, must be, our only choice left, ellipse for the last one. And that is because there are 2 squared terms and it's added. So I just need you to be able to go through and identify if it's in the right form to be able to tell what those are. All right, well, sometimes it's not in the convenient graphing form. It's in the standard form. So I have a table here, a chart that I think will help you quite a bit for each of the different forms. If you look at the general form up at the top, versus the standard form of the equation, I need you to be able to tell from both. So let's talk about the general form for a circle. The important part about that is when you look at the equation, the a value and the c value have to equal each other. That's the coefficient of each of the squared terms. They have to be the same. So you end up with a radius that's the same in all directions. So the r is a constant. For a parabola, either the a or the c has to be 0. One of those two have to be 0 because that would mean you only have one squared term. So you only have either x squared or y squared. So then it would be a parabola. For an ellipse, a and c have the same sign, and they can't be equal to one another. Because if they're equal, then it's a circle. So same sign meaning both positive or both negative. So not one of each, not different signs. So same sign, and they can't be equal to each other. Because if they were, then it would be a circle. So they are different numbers. And then the last one, hyperbola, the a and the c, the coefficients of the squared term, have opposite signs. So opposite, so one's plus, one's minus. Doesn't matter which is which. That'll just determine what direction it opens, either up, down, or left, right. So those are the big 4. It's pretty easy then to be able to tell if you have it in the right form. All right, so we're just going to go through a couple of these. So we're going to identify the conic section for each one of these. So let's look for squared terms. So this one I have 2 squared terms. So just things to keep in mind. So 2 squared terms. The a is 3 then, and the c is -2. So they have opposite signs. So which one of those 4 would it be? So 2 squared, we can eliminate parabola. And opposite signs means it has to be hyperbola. So we don't need to have it in the graphing form to be able to tell that. That's the whole idea. All right, let's try another one. So take a look. How many squared terms do you see? That's always the first place to look. Then we look at coefficients. I'm only seeing one squared term here. So if it's one squared term, that means it's a what? Parabola. There you go. So only one squared term, it's a parabola. And this one, because it's the x squared, it would open up or down. All right, take a look at the next one. How many squared terms first? So I see 2. So 2 squared terms. And for that, we take a look then at their signs. So the a value is -4, and the c value is -4. So when we take a look at those two, they are equal to one another. They are the same sign. So this must be a equals c, same sign, a circle. All right, if they were different signs, then it's a hyperbola. If they were the same sign but different numbers, then it's an ellipse. Okay, last one of these. So take a look at your terms. There's two squared terms. So two squared terms, that eliminates parabola. The a value is 8. The c value is 5. Okay, so a is not equal to c, but they have the same sign. So which one would that be? Only one left, right? It's got to be ellipse. So if the values had been equal, then it would be a circle. All right, well, if it's not in that nice form, we can still be able to tell, to be able to graph and do all that good stuff, but we want to be able to identify what it is and put it into the right form, and that's what you guys have been doing the last couple of days. So these last couple will just do that. So this has two squared terms. So we have two squared terms, and the a value and the c value are both 1. So what type of conic would that be? So same value, same sign, would be a circle. Okay, so I'm going to have you guys put that into your standard form for a circle. So we're going to get ourselves organized here, put our values together. And the y squared is fine as is. We'll move our constant to the other side, and I'll put our plus blank over there. So I'm going to have to add half the middle, and squared would be a 1, which means I'm going to add a 1 over there. So we have x minus 1 squared plus y squared equals 9. So the circle, the center, is at 1, 0, and the radius is 3. So we can make a quick sketch of that. Center is at 1, 0, and I go 3 in each direction. That's terrible. There you go. Beautiful circle. Hopefully yours is better. So you can get it into the right form, but we still knew what we were dealing with before we started this general form. All right, let's take a look at the last one. So I have two squared terms, and the a is 9, the c is -4, so they have opposite signs. They're not equal, so this is a hyperbola. Okay, so let's see if we can get it into the right form. So we'll group our x's together, and then we're going to group our y's together, and we're going to move that constant to the other side. Okay, remember, if you have a coefficient that's not 1, we need to factor that out. So x squared plus 4x plus blank, we'll fill that in, and then we'll pull out a -4 for the y's. Make sure that's a -2y then, so be careful on your sign. And then, whoops, equals. On the other side, we'll have 4 plus blank plus blank. Okay, so we'll figure out what I have in the middle here. So we have half the middle squared would be a 4. So what we really did then is we added 36. So over here, I'm going to add 36. Okay, what I do here would be a 1, half the middle squared. But what I really did is -4. So that would be a -4. So I have 9 times x plus 2 squared minus 4 times y minus 1 squared equals 36. And remember, for hyperbolas and ellipses both, we have to go ahead and divide through, get it equal to 1. And hopefully it's divisible and it works out nicely. So x plus 2 squared over 4 minus y minus 1 squared over 9 equals 1. Okay, because the x is first, that means this one is opening left, right. And let's see, our center would be at -2, 1. My a value is 2, and my b value is 3. And we can go ahead and do the graph of that if you need to. So I think we should be able to be fine with that. So a is 2, b is 3, so you can do your major, minor axis and all that. I'm going to save the sketch for you to do on your own, just so you get the basic idea. So we definitely can tell what they are by looking at the general form, but the standard form is really handy for graphing. All right, so your assignment for this section here is page 667, and we're doing number 13 through 17. Notice the change in the directions. I do not want you to graph it. I just want you to identify what it is and write it in the right form. So just identify and write it out. And then 19 through 23, those you're actually going to do a, just identification, I believe, as well. I think we're just going to graph a couple of them at the end. Let me double check and make sure that we're doing the right thing there. Yeah, so the 17 through 19, you're just identifying. And I believe all the way through. I don't think you're going to have to do a lot of graphs. Let's just say that. So we're only just identifying and putting it in the right form. All right, so hopefully that gives you a quick overview, and enjoy your 10-6.